So today we're going to measure and classify angles. Now, usually when we measure angles, we would use a protractor. However, we don't have like a supply list here or anything, so I'm not going to expect you to buy a protractor. I do have a bunch if you ever want to see how it works. But I'm going to show you a picture of it and show you later on in the slides here how you would use one. Just in case you encounter maybe a picture of a protractor, say on an SAT or a PSAT, and how you would read it. So our first slide is got our definition of angles. And an angle is formed by two rays that have the same endpoint. The rays are called the sides of the angle. The common endpoint is called the vertex of the angle. When there's only one single angle, there's going to be three ways to name it. You can either just name it by its vertex or using 3 points on that angle. And I'm going to talk about this momentarily here. Okay, so there's three ways to name the picture of this angle down here. And here are the three ways that are listed. So we can either name it, when it's only a single angle like this, we would name it by the vertex angle, or the vertex point, which is going to be angle N. The other two ways would be to name it with the three letters. So we would start at the P, and then we could go to the vertex, and then to the O, so P and O. Or we can go in the other direction, where we could start at the O, and then go to the vertex, and then to the other end over here. So we could name it in either direction. Notice the middle letter of when we use 3, is the vertex angle. So when we name it with 3 letters, that middle letter needs to be where the two rays are meeting. So N is the vertex. And again, the sides of my angles are created by 2 rays. Now, our little symbol for angle is this little slanty L looking thing. So notice if I wanted to name this angle right here with just one letter, I could say angle N. Otherwise, I would use 3 letters. Now, when there is more than one angle sitting at N, we have to use 3 letters. And what I mean by that is, let's say I redraw this thing, and I have my P, and N, and O, and let's say I draw another ray here, and I call this Q. I can no longer name any of my angles with just the letter N, because I actually have 3 different angles going on here. I have this big one, then I have a smaller one right here, and then another one here. So when that occurs and you have 3 different rays going on, you're going to have to name the angles with 3 letters. Good on that? We're going to see that on the next slide. Now, also, when we took the quiz yesterday, and you had that question that said, name a pair of opposite rays. Remember, when you name a ray, you need to put the picture of the ray on top. So if you forgot to put the picture, like let's say you just put MP, to me that's a segment. If you put a picture of a line on top, that would be wrong. That's a line, that's not a ray. So it's important that you label your letters appropriately, depending on what they're asking for. All right, let's try the next. Same thing that we just talked about. Notice my vertex point here is B, and it's being shared. So when I have a situation like this, I cannot name any of the angles that are here with just one letter. I need to name all of the angles that I can find in this picture with 3 letters. And there's actually 3 different angles going on here. So I have 3 angles in this picture. I'm going to show you what they are. The first one, okay, is the main angle. It's the ABC. So I'm going to outline that in red. So that first one is, and I'm going to put the little slanty L looking thing, so I'm going to label it as ABC. Remember, you can also go in the other direction. So I could also call this angle CBA. Now I also have a little piece, ABD. And again, put the slanty L looking angle symbol, ABD, and then I can go in the other direction, DBA. And now I have the last DBC. And I can go in the opposite direction, CBD. And again, notice when I rename these, notice the middle letter is the same on all of them. That is your vertex point. That is where the vertex of the angle is located. So in this example, I can't name any of these red, blue, or green angles with just angle B, because it doesn't specify which angle I'm referring to. Okay, so when we are asked to measure an angle, we use a tool called a protractor. Angles are measured in degrees. We can classify an angle with 4 different names. So there's 4 classifications. We can have an acute angle, and that would be an angle between 0 and 90. We can have a right angle, which equals exactly 90. So when I have my angles here created by 2 rays, a right angle will be indicated with a little square box, or they would show that it measures 90 degrees. We can also have an obtuse angle, and that would be an angle between 90 and 180. And then a straight angle equals 180. So a straight angle is almost, it looks like a straight line. One way that I remember acute is it's a cute little tiny angle. So it's the smallest of the 4 classifications. This one. Okay, so for this first example, it wants you to draw an angle, label it with your initials, then measure it, name the angle 3 ways, and state the measure of the angle and classify the angle. Now, we don't have a protractor, and if you try to bring in a picture into Notability, you're not going to be able to manipulate it. So I'm just going to show you how a protractor works. I'm actually going to bring in a picture of one. So, and show you how it's got 2 rows of numbers. All right, so this is what a protractor generally would look like. It'll have a little hole usually here in the middle of it. Let's see here. And generally what you'll do is you'll take your protractor, and let's say you had an angle that was drawn here. You would first line up either this side or this side with one of the rays. So I'm going to line it up here with the red line, because notice how it's pointing here at the 0. So this will be my first place where I start to measure. And then let's say it went up here. So notice that I've got 2 rows of numbers. If you think about it logically, it's going to start at 0, go to 10, 20, 30, 40, 50. If you were to extend this out here, you could see that this angle measures 70 degrees. So we would not use the outside numbers. Now, let's say our angle was put over here, and our first ray was here. And then let's say it went up this way. This is where I would use the outside numbers, because again, I'm starting here at 0, and then I'm getting larger as I go around. And this measure over here would be 110. Now notice what's going to be coming up is our segment addition postulate. I'm sorry, the angle addition postulate. So notice this is a straight line. And if I add 110 plus 70, that equals 180. And that's going to be what's coming up in the next couple slides. However, when you're using your protractor, if you are going to start measuring from this right side, you use the inside numbers. If you're going to make your ray over here, you would use the outside numbers. A good reference angle to always have a gauge to see if it's acute or obtuse is the right angle. So if you can see that your angle is going to be smaller, like in here, you can realize that it's acute. If it's going to be wider than this one, then it's going to be obtuse. A lot of times you could take the corner of your paper and you could sit it in there. And if your angle exceeds this corner, you're going to see it's obtuse. So the corner of your paper is a right angle. So this is like a little tool you could use to gauge to see what your angle measure is. So this is a protractor. Again, you're not going to need to measure any angles on your test or quiz, but just be aware of how a protractor works. Now, this angle here, the green one here, is you can see that it's going to be an acute angle. It's less than 90. But the blue one over here, this one is obtuse. It's greater than 90. So if it asks you to classify, it's expecting you to tell me, is it acute, is it a right, is it obtuse, or is it a straight angle? All right, next about postulate number 3. And again, the number postulate 3, I don't care that you memorize that. I just want you to memorize what the protractor postulate states. And this is similar to the ruler postulate. So all this basically says is that every angle could be measured with a degree from 0 to 180. So you would pull out your protractor and you could measure every angle using a protractor. Yes?
Postulates are basically laws.
Yeah, they're like rules. There's something that doesn't need to be proven. So they're sort of even... Let's go there. Now, we already talked about the segment addition postulate. Now we have the angle addition postulate. So it works the same. If we have two little angles and we add them together, that will create a larger angle, just like we did with the segments. So for this one, if we have the large angle here, or let's do them in smaller pieces. So if I take AOB and I add that to BOC, that's going to give me the larger angle or measure of it, AOC. So let's say I put some numbers in here. So let's say I told you that angle, the measure of AOB was 20. And the measure of BOC was 30. I can figure out that the measure of AOC, this whole big one, is going to be 20 plus 30, and it's 50. So you can take it and add it piece by piece to get a larger angle. Now, notice for this angle addition postulate to work, you're going to need a ray here with a point in here. So you're going to say if point B is in the interior of this green angle, which is right here, then you can say that you can split it into two pieces and add them up. Same thing if you have a straight angle. And if you have a point, and they're calling it here point M, that's not on the straight angle. So here's my straight angle. And if I have a point M that's not on it, I can now make two smaller angles. And I can say here that JKM plus MKL equals 180 degrees. This little m in front represents the word measure. So the measure of JKM plus the measure of MKL equals 180. So let's say JKM was 110, and then I could see that MKL, because it has to equal 180, could be 70. So that's the only figure in geometry that you can assume is when it's a straight line, that it's a straight angle. So this is just like our segment addition postulate. And again, we could abbreviate this, like when we're writing it as a reason for a proof. If you want to put AAP as the reason, that's okay. Just like I told you for segment addition, you can call that one SAP. Otherwise, you're going to write out the word angle addition postulate when you write down your reasons. Next, we're going to talk about congruent angles. So just like we had congruent segments, congruent angles have equal measures. So again, you may have little markings on it, like they have here on angles A and B. Notice the congruency mark. Again, remember the symbol for congruence is the equal sign with the wave on top. And again, congruent angles, all that tells me is that angles A and B have the same measure. I don't care what that number is, but when you have the measure of angle A equals the measure of angle B, that's when I might pull in numbers. So I might show a 30 here and a 30 here, and then I could show that 30 equals 30, and the two angles are equal. But as far as congruent goes, I just need to know that they're the same size. I don't care what their numbers are. Next, we'll talk about congruency marks. So again, we just saw that. Just like with the segments, there are these little tick marks. So this would indicate that for this segment, I could state that segment AE is congruent to segment ED because it has the same congruency marks. I can also do the same thing for angles. Notice E here has two angles or three angles coming out of it. So I can't just say one letter, can't say angle E. I need to name it with three letters. So notice this angle has this same mark as this one. So I can show here that angle AEB, so let me write that out, angle AEB is congruent to the same angle over here that has the same mark, and I can call that angle BEC. Now I could have reversed it, said BEA and CEB, but I'm showing because they have the same congruency marks that those angles are congruent. The other marking in this picture is this little box. This indicates that that angle is a right angle. So you could also state from the markings here that angle CED is a right angle. So you could write a sentence about that. You could also name it in reverse and call it DEC. So this is what you can tell from the picture, that we have two congruent segments, two congruent angles, and we also have a right angle in here. Again, remember, if you have something that looks like this and it doesn't have that little square there, we can't assume that this ABC is right unless it's got the little box. So we can't assume it even though it looks like it's a right angle. All right, next we're going to talk about an angle bisector. We already talked about a segment bisector, but an angle bisector does exactly the same thing. It is going to split our angle into two congruent angles, so two smaller congruent angles. And there'll be different ways that you could look at the picture. by looking at congruency marks or by looking at angle measures, or they might even just give you little phrases here telling you that BD is the bisector. Okay, so a bisector of an angle is going to be a ray that divides the angle into two congruent angles. So for example, I have the large angle here, ABC, and then I have ray BD right here that is bisecting this angle. When you see a statement like that, you need to know, or you can conclude, that the two smaller angles that it just makes are now congruent angles. And in the picture, they'll either have the congruency marks or they will show you the value of how big that angle is in degrees. So they're either going to write out words like this, or maybe they're just going to say BD bisects ABC. They will also show you that this angle here, ABD, is congruent to DBC. And they could give you a congruency statement. When you see different statements like this, this will lead you to believe or realize that that angle has been bisected. Let's practice this now. We're going to give some other names for each angle. So again, let me trace around it. So I'm going to trace around DEB. So I'm going to start at D, go to E, and then go to B. So I can see that another name for this angle is going to be angle 4. So sometimes your figure will have numbers sitting inside your angle. So you can use that number that's inside the two rays to name the angle. Again, another way to name DEB is I could reverse the letters, and I can call this angle BED.
Wait, so new one will be fine?
Correct. Now, I could have also gone past the D on this one, because remember, the ray keeps going. So another name for this could have also been CEB. So I could have also called this CEB or BEC. And you'll put the little angle symbol in front. So these are 5 different ways to write that first angle. Now notice all of the ones that have the 3 letters, they all have the letter E in the middle. You need to have that vertex point in the middle of the 3 letters. Let's try the next one. I'm going to go from C to B to E. So here is my angle. Notice I can name it with angle 8. I can also reverse the order and name it EBC. So that one only has 2. The next one. It's telling me to go from B to E to A. So I'll go in the order. So B, E, A. I can name this angle 3. I can also reverse the original letters. Call it AEB. That's it on that one. Next one, DAB. So D, AB. So I'm going to go from here to here to here. And you can see that I can call it angle 1. I can also reverse the letters, BAD. This one also had a point beyond it, so I could also go back and call this angle CAD or DAC. Again, the middle letter on all of them is the letter A. Next, we're going to talk about angle 7. So angle 7 is over here. So I'm going to draw in the sides that are creating it. Now this one has a lot of different names. So for this one, I could either go from E to C to A. So I can call this ECA. I can reverse it, ACE. I can also, instead of using this N guy, I can start at the D. So I could go from D to C to A. I could even have stopped here at B and gone from D to C to B. Because again, remember, the ray keeps going. And again, I can reverse all of these also. So I could also have said here, I could say, go in reverse, A, C, D, or B, C, D. Again, remember, on all of these, the middle letter needs to be that C, where the vertex is. Next. Also, there's one other name. Notice on this one, there was only one letter C here, so I could also call this one letter C, or angle C, because there's not 3 rays coming out of that. All right, the next one is going to be angle 9. And angle 9 is right here. So again, the rays that are going to form it could be here. So I can also, now I can't call it letter B because it's got a 9 and an 8 by the B. So for 9, I need to name it with 3 letters. So I can either call this angle EBA or angle ABE. Those would be the 2 for angle 9. Now we're going to use that angle addition postulate and figure out what angle we're going to create when I add 1 plus 2 together. So when I add angle 1 plus angle 2, I'm going to create this larger angle, and this would be the measure of angle, I could call this EAB. I could call it EAC, or again, I could reverse it, BAE or CAE. And again, the measure of. So I'm adding up the 2 angles together. If I were to add 3 and 4 together, so here is 3, here is 4. Together, they're going to now make the larger angle, and that one's going to be the measure of angle AED. I could also say it is the measure of angle AEC. I can also say in reverse, I could say it's the measure of angle DEA, or even the measure of angle CEA. Again, middle letter is where that vertex is, and it's angle E. Yes? You could also put angle E when you're talking about all of it together. Yes. Yes.
Can you do B?
Actually, no, on this one, because there's two other angles, we're going to name it with 3 letters. I'm sorry, say it again.
Can you do BEC?
BEC, for the whole thing, no. We have to use these guys over here on the sides. And then E has to be in the middle. So we either need to go from A to E to C, or A to E to D. But we can't use B to name that. And then we can't use just one letter because, again, E has 3 different names for it. All right, let's do 5 and 6 now. All right, so 5 and 6 are over here. Notice they're sitting on a straight line. So I can conclude that the measure of this is going to be 180 degrees. However, let me name it with the 3 letters. So 5, and the measure of angle 5 plus the measure of angle 6 is going to give me the measure of angle EDC, or I could also call it CDE. I could also state that the measure of angle 5 plus the measure of angle 6 equals 180 degrees, because this is the only angle that I can assume from a picture that is a straight line. So we will be using information like this in our proofs, realizing that we have a straight angle here and that we could add them together to get 180 degrees. Okay, so that is the end of the notes for section 4. Your homework is section 4, the PDF there. Again, any of the protractor questions, if you don't have a protractor, you can skip over those. I'll cover them and talk about them in class tomorrow.